closer.
Hello? More closer?
It works.
Okay.
Stage is yours.
Perfect. So myself here in Sharma, and I work as software engineer at Clicks in news team. So today I'm going to talk a little bit about what I meant by content as a service, and one aspect of it is how to build real-time news search engines as well, almost real-time. So a little bit about, of course, about Clicks is we have a packaged search in the browser itself. So when you type something on the URL bar itself, then you will, in the drop-down, there are some of the suggestions for that specific search query comes to you. And we shipped it as an extension, and now it's backed a lot by Mozilla. So in coming weeks, you will listen more about this. And today, I'm going to talk about a very simple thing which people think in the search engine. That's what a search engine is. You type a query, you get the result. But this is the scenarios, and the game got a bit changed when we talk about news in search engines. So let's I know if you haven't heard about Clicks and never used it, most probably. So that's how it looks like. For example, if you type FC-Bind in the URL bar, then you are seeing like the homepage for FC-Bind, what are aggregated results here, what was the last matches of FC-Bind, few other normal snippets from Abendzeitung or something like this, but that's technically it. But as previously mentioned, another realm of the search queries are either they are navigational, for example, CNN.com, you want to go BBC.com, or they are more free-flow search, like what's my cat likes to eat tonight. So that's why it's another thing is if you type something, then we show like top 3 trending news, and I will come to this particular use case later in the presentation as well. So let's look at the first snippet again. So the first result here is also a news result. For FC-Bind means, I think the old coach wants to train the FC-Bind again after a great run from Ancelotti. So how do we do this? And I would try to map this, connect the dots going forward, and then seeing the things that how do we build like a scalable architecture here. All right. So here's the line of thoughts here. I will make sure that everyone feels comfortable here when I talk about content, what I meant by it, how we transform it into a system architecture, combine it with the search functionalities, and at the end, of course, there are bumps in the road, so nothing is for free. So what the challenges that one might face when they are developing these kind of technologies. All right, let's go for content. So when I say about content, I'm not talking about like Buddha, like I'm feeling content right now. No, it's something tangible. Right? It's like an entity. For example, if my friend Donald Trump is tweeting about Kofefe, if you guys remember, it's also an entity here. It's a tweet, right? Your friends are putting pictures on Instagram, it's going crazy there, your Facebook going crazy, everyone going crazy on social media nowadays. So then another thing which can form the content is your online newsletter. So like I'm pretty much sure that you guys might be associated with 1 or 2 different communities, and you are getting a newsletter in your feed. That's also a content because it's giving you some sort of information here. And of course, most of the time when we think about content in the news perspective, we think about, oh, we have breaking news today, something. And news plays a lot of part into providing content to the different people, into the different aspects of life. So let's see why the content is so important, and specifically in content when I talk about like why news is so important. So of course, it's an information hub. You want to search about, okay, what is the current Python technology? What is the last Python technologies? What should I learn more about deep learning, machine learning? All of this like an information hub, so this giving you an information. Another thing is it keeps you up to date. Means if you are still using, I don't know, no, nothing against linear regression modeling, but if you are still using very old knowledge, then you are losing the pace with the current technologies which are evolving. It's just as an example. And the third and my absolute favorite is it shapes our reality. So for example, there was very funny when I was first working with this data. I got 2 news articles. One was saying, coffee increases chances that you get depressed. 75% study shows. And others says like, well, coffee increases the productivity by 80%. So you see, they are like the negative tone of voice, and there's a positive tone of voice. And that can really segment the users, and it can really affect that how we see or how we perceive our own world right now. So let's start building this thing up, that how do we do it? So one thing that distinguishes news from every other aspect in the search engine is that we cannot afford to be delayed. We cannot use the articles from 2012, 2015. It has to be continuous, as I'm speaking right now. If there are new news articles coming, this should be injected into the system. That's why we deal a lot with the streaming data in large volumes. As an architecture, in the news team, we used core Python as a backend technology, and for database technology and for the search engine capabilities, Elasticsearch and Redis. We have from the very beginning in the team, we boasted upon containerized architecture, because when we go tomorrow for the scaling, there was not a new word when I was using Docker like 3 years ago, and every service is containerized, so you don't need to write monolithical codes and then pushing it to deploy to server. My goodness, that's a nightmare. Don't do that anymore. Or if you have a very good reason, please continue doing that. Second, why the container also gives another very big functionality to us is scalability. Not only horizontal, like adding machine one after another, but vertical as well. You can just make up and down your containers and services. And because I'm talking about search engine perspective, responsiveness is also very important. I can type a result, and if I'm giving you news back after 30 seconds, you guys will see like, man, maybe I should read the newspaper from the street, because in 30 seconds you can do that. That's not possible. We need to give a normal human eye can perceive the difference between the result for 500 milliseconds. So we are giving in 10 milliseconds all the recommendations that we have. So let's start about how we start building. So of course, you need data, as always. So we rely heavily on Twitter, RSS feeds, and the Facebook data. So because Twitter, we follow some Twitter accounts, like for example, of Spiegel, your CNN, Breaking News, or BBC. Similar for the Facebook, and old school RSS feeds as well. It works pretty well. So let's look at the life cycle of how a news article URL looks like. It can be discovered from any of these sources, and then it goes through the processing cycles here. So for example, let's just come from the RSS feed. Till this first layer, which is written Twitter streamer, cluster 101, Facebook streamer, it's completely raw data, like a raw tweet, raw Facebook post, raw RSS feed entity. Nothing has been processed and parsed yet. So of course, there's a dedicated services which are scalable for the traffic which is coming from all these 3 sources, and they are trying to detect that there's a URL in the tweet, of course, and also to take out the snippet of that URL from the tweet. For example, what is the title, description, main image, and what is the publication date of the URL as well. And all of these things all of these URLs are being fetched, and this component is responsible for that. So far, we have some sort of mix between social engagement information and also about what the article is talking about. And let's say that how do we index this now? So at this stage, after the processing data, in very simple words, we start to index it into our engine here, which is called News Indexer. And next slide is dedicated to it, because it's kind of a core soul truth for us. So if you want to search about any news article, you can just go to this engine, use the web API, and then you will get all the information that from how many sources we found it or not. And of course, as always, for the latency reasons, you can always use news caching mechanism so that you don't respond back like very slowly, and then you don't hit again and again the indexer, which might be computational heavier. So let's look at what the news indexer looks like. As a database technology, we use Elasticsearch here. How many of you have heard about Elasticsearch? Very good. So I can skip that part. Elasticsearch is basically document-based NoSQL solution. The guys who does not know it, in a very simple word, it's distributed, so it's very good to form the clusters, and then scalability is child's game here. So let's look at it. So first thing is that all the process data which is coming into our systems is being fed into the Elasticsearch. But let's look a step backwards, that how the indexer is getting it in a way that it can scale. So now next question, how many of you uses here Amazon Web Services, AWS, or have used? Okay, so I need to talk about it. So there is a SNS is a service from AWS where it's more or less like publish subscribe system. So what is an SNS? You can publish a message on SNS, like as a notification, and then you can plug in the subscriber to this channel so that they can read this message. Very simple, publish subscribe. But it's asynchronous and scalable. So for example, there might be the messages coming into the SNS right now being published, but you can plug it and play anytime. And in this case, SQS, Amazon SQS is a queuing solution, so it's reading the messages from there. So it's a subscriber. So it's pretty asynchronous, and it gives the power to make it scalable. So all this process data from all these 3 different engines that I talked before, they are basically pointers to this S3. So what is S3 is nothing. It's just like a big rack of hard disk, I guess so, and you just store your files there. And that's what Amazon S3 is all about. So every service sends an SNS that, hey, I have a process file which I have sent to S3. And then SQS reads to SNS. And of course, indexer is have all the SQS services here. So it goes to the S3, take the process data file, then push it back into the indexer. So for our use case, it was very important that we store data like on a snapshot basis. Like, what are the news articles that we have seen today? What were the news articles that have seen 7 days ago? So it's like a daily-based index. It's like a date-based index. And that's why indexer is just storing the data into the date-based index into Elasticsearch. Then another concept which has come into the Elasticsearch as such is called aliases. I really refrain myself to use any of the jargon words during the presentation, and I'm sorry that alias is the first one that I'm going to use, but let me explain that pretty quickly. So alias, as the name suggests, you can group some different indexes together under one umbrella term. For example, if you want to see all the articles that is being published in last week, you can just make an index or an alias named week index, and this will point to all the 7 days index. So technically now the Elasticsearch will take care of you whenever you hit or search for an article or articles. It will automatically parallelize your query on all of these indexes and then get the data back. So it's very, very, very smooth concept here. So it's like alias manager is managing the index under the similar names, and also it's using like deletion of the old indexes. Like, we don't want to keep data for like years here because it has to have data till 1 week, but we are keeping from 1 month just for the analysis purposes. And then, of course, I think we as a developer, we really hate manual work. That's why we have computers and the algorithms and whatever we like to do to make it automated, and that's why the updater is doing. So you don't need to, we don't go on the machine and say like, hey, Elasticsearch, these are new files that you should process, or like this is a new information for you. No, it's happening, everything, updater is reading the new files being uploaded on S3, and if there are some changes that has to be made over Elasticsearch, that's been happening there itself without me knowing at least. And as a wrapper, there should be a web API with which you can query the data from Elasticsearch back into whatever service that you want to consume. Okay, that was all about the system, like how this architectured, and now it's ready, ready to rock in the sense that now you can use it for your search processings or whatever you want to do with this later on. So I will divide it into two categories. First is like how you do a search on the basis of when you have this sort of interface. Ranking, that how do you rank your results when you are typing or answering back for any of the search suggestions. And then the second topic will come of clustering, and then how do we detect trending words which are happening right now. Okay, so for the QSL, we have derived our own query language. So this thing that I really like to do is giving the power for the people who are not technical. So don't make the things complicated. Things are a lot complicated already when it goes into the scalable and the multi-cluster environment. So if you look at this query, it's very simple. I'm talking about Tom Petty, the guy who died, unfortunately. There's musician singer. Guys, nobody knows? Oh, shit. Rest in peace. And so Tom Petty. So I'm interested into Tom Petty articles from Spiegel.de, which is the website in Germany that I trust. This should belong to the music category. They should come from this specific Twitter account, which belongs to official Spiegel account. And they should be in language German. I'm trying to improve some of German here for me. So that's how you will get as an answer back from the engine. And this is just like a dashboard where you can see that how the articles belonging to this query are grouped together. So for example, you can see that this we discovered all from all three sources, like this. But it has like a lot, we discovered it from a lot of different other Twitter accounts that we are following, unlike this guy, which only 2, still not too bad, and the different discovery time for these articles. So we discovered these articles on different time. So technically, it's like a window for you that if you want to make any of your search queries into this specific query language, and then you just push it on the engine, and then you will get back the answer. And then the answer looks like this kind of news articles for you guys. Okay, so almost real-time ranking. So let's go back to this use case. If you type spiegel.de, then it's very essential for me to know that what are the top 3 trending news that are relevant for this query, spiegel.de, and of course from Spiegel. So here, what we try to do is we try to balance out the engagement in the social media and also about the discovery time of the article, that when did we discover this newsletter article. And this is like a cat and mouse game. So because if you give more weight to the engagement score, then the newer upcoming trending events, they will starve. While if you give a lot of weight to the recency of the articles, then technically you will, every new articles, no matter how relevant for this world that article is, you are just going to keep on giving, 30 seconds ago, 20 seconds ago. But that does not mean that it's like a trending event. It's just like a recent event, a recent news article. And another thing one can really experiment with is function scores in Elasticsearch. So what are the function scores as a concept is, when you are querying Elasticsearch, you can tell Elasticsearch that, hey, rank my articles that you are giving back me as a result into this specific algorithm or this specific ranking functions. And you can do this as you, means I used to do it like 3 or 4 ranking functions in a minute, and then to see that how the list of articles changes according to this. And as I always say, there is no one true ranking. So you need to experiment, you need to bleed, and then to squeeze out that what is the signals and the mix of signals that is working for you. Okay, so let's go that why do we need clustering then? Like, okay, so I'm ready. I have my data in Elasticsearch, it's fast enough. Whatever the query, I will file into this. It will give me some results back. It's missing one important thing in respective to the free flow search, is missing the context. So if I'm typing right now about Donald Trump, well, the guy is technically trending all the time, but if I type Donald Trump, the news can come out is like, hey, Donald Trump has a new golf course. Not maybe relevant for golf lovers here, but not to me, honestly speaking. But then we will miss out the news, which is like Donald Trump is talking about Puerto Rico right now. So we need to have a context for every search queries, and we cannot just answer back for all the search queries. So that's why what we did is we started to cluster the articles from the trusted news sources which are talking about the same topic. And we started to build these topics throughout the day. So the topics will build, and that one topic contains some list of articles, between 15 to 30 articles, which are talking about the same topic. So that's why we are doing here topical clustering. And once the topical clustering is done, the second piece of puzzle to solve here is to have the representing terms which should trigger the articles for these topics. For example, in this case, Puerto Rico, Donald Trump commentary, or these old kind of words, they should belong to one of the articles which is talking about Donald Trump's comments on Puerto Rico. And of course, representing terms are not enough. You need to do word transformation, like word embeddings and everything, so that you can answer for the similar terms which are talking about the same topic, but they are not the part of the text of the article from which you extracted these terms. Once this is done, so now technically your search engine is ready. But another aspect that comes with this particular architecture is it should be self-serving. Means your data sources, I should not personally go to the Twitter or one of my colleagues in the team and say like, okay, now I'm pushing this Twitter account to follow, this Twitter account to follow, this Twitter account to follow. No, it should be happen in an automated way. And search queries should be expressive in the sense that even the people who are not technical, they can also understand that what kind of queries I should make so that I can extract the news data from our systems. And embed your own ranking algorithms. Means there is no true good working ranking algorithms. It's working today, it will fail tomorrow. And that's why I try to experiment with your ranking algorithms as much as possible. Build dashboards, because dashboards give, means like I like to see JSON files a lot, but generally people don't. And so that's why I built like the dashboards for it, so that you can really see that how the data is looking like from a human perspective. I'm not saying that I'm not human, but still like in a more insightful way that it can done here. And technology is not enough. You can build like a very scalable systems and everything, but without the manual efforts, without the manual testing, a lot of user testing, a lot of user input, it's all failing because the news is pretty fast and it's pretty dynamic. It's like elastic fiber. So it really shrinks and extends. And that's the thing you only get when you have the experience with the newsletter curation in your team. Okay. The bumps in the journey, which were for me, I talk with, like generally when I go to the meetup, many people say like, okay, so I will just dump all of my data into Redis or Elasticsearch and I have a search engine ready. Answer is nope. You need to model your data, because if you don't model your data, then you are using enormous amount of